Hi guys, so I'm catching up on my next video. In this video also we have a sample C program. In previous video we just covered that how a basic main function looks like and how that looks like in assembly. So in this we have a variable declaration, nothing but a hexadecimal value, nothing much fancy going on here. So what I'm planning is I will cover variable declarations first, basic types, not all of them, and then we will talk about the if statement, decision making, those things, and then looping, and then functions, and then pointers, and then the structures and unions, and probably global variables and stuff like that. And then we will end the course here, and we will jump into some real world reversing like sample crack me softwares, stuff like that. And then finally we will jump into binary diffing the Windows updates. So what happens is when Microsoft releases patches, not all the time they tell you what the security bug they fixed. So they will give you a CV number that there is a vulnerability in Internet Explorer, but they will never tell you that what exactly the vulnerability is, or even where that vulnerability is. So they will never give you that information. So for that we do the patch diffing. So we will be probably using IDA Pro that time. So this is not what I'm talking about. This is much later in the course. Right now we are just looking at C programming and the disassembly, and we are just getting hands dirty on WinDbg. And so that's why I highly encourage you to play with WinDbg, and this is a very important tool if you want to do anything substantial with exploit development and malware analysis. So basically this security research field, you have to have very good hands-on on this. So anyway, so this is our sample program, and I have compiled and linked it, which I showed in the previous video how to do that. So I will not go through that again. I have already set the breakpoint and we are at the main function. This is our main function. Nothing much here. So the preamble code. Some interesting thing that we see here is push ECX. So I don't know what the hell that is. So this is what the compiler does for you. You see, anywhere where I'm doing anything like initializing something to 0, but the compiler has already done this. So, and then this is familiar, XOR EX EX. So it means that XOR with the same. So this is a binary operation. So if you XOR two binary numbers which are of same value, they get zeroed. If they are different, they get to be 1. So if you XOR something with that, so it will be 0. Now EX register stores the return value of a function. That's the very special register. You could use some different register also, but you will have to write an assembly code for that. So now the compiler takes care of that, so it stores that in the EAX. It's not that only in EAX you can store the return value, you can store anywhere you want. So the interesting part is this one. So what's happening is move dword ptr EBP -4. So it means wherever this EBP is pointing. So let's see that where EBP is pointing. EBP. So it's this one. Also you can see from here, this is 116FF08. So EBP is over here. And if we scroll that, so now how the memory layout is, it's from higher to lower. So EBP is pointing at the base of the stack. So to explain that, I have drawn a very awesome diagram. You know, this is the world's awesome diagram. So I'm sorry, this is the best I could come up with. So what happens is when the program is loaded, at least a thread runs. So it will get some section in the virtual memory. So what happens is this blue thing is a stack frame. It is given for that function to process on its local variables, to add, subtract, stuff like that. So the base pointer always points to the base of the stack frame, and ESP, extended stack pointer, it points to the top of the stack frame. So now this always goes from higher to lower. Okay, so that's the key there. That's and that's what we see over here. So if you see, the numbers towards the bottom are higher, and as you go up it's getting lower and lower. So as you see that F2, now this D8, so it is decreasing. So if you see decimal value, if you are not comfortable with hexadecimal, so you can see over here it's 22, now it is 08. This is 40 and 26. So this is going from higher to lower. So our EBP is over here. This is our EBP. So it is pointing to 1C. So that means this -4 means it will be these 4 bytes. So these 4 bytes are going to store this thing. So let's get to that. So to get to that, you have to press F8 and then F8 and then F8. So this is the time when these 4 bytes are going to get initialized. F8. So our EBP is over here. EC0. EBP -4. Let's copy that thing. Okay, so this is our EBP. So these are our 4 values. So you see that the order is different. That's because of the CPU architecture that we are running. It's Intel, so Intel is Little Indian. Little Indian means least significant byte is stored first. So the least significant byte would be this one, and then most significant byte would be this one. Now in mathematics, the significant figures are anything after the decimal is ignored, so we do not have a floating point, so we'll not talk about that. So it's an integer. So if you have something like 0000, so till this point, so the most significant would be 44. But since we have something 11, 22, 33, so this is the most significant and this is the least significant. So memory allocation happens from higher to lower, from 11 to 44, but initialization would go backwards. So 11 would be stored first, then 22, then 33, and then 44. So that's why you see this backwards. And then when you read it, so you will when you read it, so it will be again flipped. So you would read it like this only. So that's the way memory works, and this is very important to understand. And then there is nothing much. XOR EAX by EAX, so that EAX becomes 0. That's this thing, the return 0. And then we are just doing this is our preamble code, and also this is called the initialization code, and this is just we are going to clear the stack, because in Windows the callee clears the stack. So we have not used anything, so we will just return to the caller. So the function which called the main function, that would take control over now. So I have that's all for now, and what I am doing is this is the reference book that I am using. So this is the C language reference, the ANSI C book, and this is very simple, and I will take it module by module, and in the next video we will talk about arithmetic operations and then these decision making. So my plan is from variable declaration to decision making, looping, and so on. So to follow along, you could read this book. It's a very good book for C programmers. So that's my tutorials are based off of that. So now the listing file, if you would like to see, it looks like this. So here you would see that you have myvar dollar, but in the debugger it's like EVP -4. It's a little bit different, and this is the actual integer value, and this is the hexadecimal value. So I hope you enjoyed this video, and I will see you in the next video. Bye bye. And yeah, if you like these videos, subscribe to this channel, and so that support me, and I like it. And I will keep making these videos like this. When I myself started, so there was not much information available out there, so I learned assembly by myself, and I learned debugging and how to disassemble code all by myself, and looking at various blogs, but I could never found any videos that are teaching from very basics. Like, for what I believe is, if someone is going to do a patch diff of Microsoft Windows security updates one day, how the hell he is going to reach there if he doesn't know how to reverse a simple C program? So that's the approach. We learn how a C program looks like in assembly. We will do that to the C++ as well later on, and then we will some hands-on with crack me programs. Like, we should not crack other software, so I will not even encourage that, but we will have some sample crack me programs, and we will crack them. And then after that we will get into the patch diffing part, how Microsoft provides patches, and we will also develop some exploits. And the most interesting thing is not the exploitation but the mitigation bypasses. So we will talk about what different kinds of mitigation bypass. So you will have a lot of fun, and have a good day. Bye bye.